How come? How to get it right? Am I doing right? Perfect! You have found the best video tutorial for yourself. Good day, I am Teacher Joseph, and I'll be your tutor for this week's lesson. What we are going to tackle about might have been encountered from different aspects in our lives. So I, therefore, think that we need to master this lesson in order for you to be mathematically inclined. In this course, you should be able to simplify radical expressions by using 2 out of 4 ways, such as reducing the radicand and reducing the order of radicals, and to appreciate the concept of simplifying radical expressions. In number 1, the first objectives is define rationalization and appreciate simplification. In the number 2 learning objectives, simplify radicals by reducing the index to the lowest possible order and rationalizing the denominator of the radicand. And the third objectives, determine whether the radical expression is in its simplified radical form. Are you ready? But before we proceed to our lesson for today, we'll be having an overview on how we are going to tackle this week's lesson. We have three wise men here in our screen. The first wise man named Gaspar. Gaspar gave Jesus a gift which is signifies um the kingness, the royalness of Jesus in this earth. Now, gold in our lesson symbolizes our review because review is very important to our lesson because in order for you to understand this week's lesson, you should be able to master what you have encountered or what you have learned last time. Okay? So the second wise man here at the middle is named Melchor. Melchor gave Jesus frankincense. Yes, frankincense signifies deity. Yeah, the godness of Jesus Christ or the godness of the Father. Yeah, in our lesson, this symbolizes our lesson proper because this will be our core theme of our discussion for today. And the third wise man is named Balthazar. Yes, Balthazar gave Jesus Christ a mirror. A mirror. Yes, it symbolizes death. But in our discussion, this will be our generalization. Yes, it's like summary. Okay, now let's proceed to the first wise man, our review. Okay, what you have tackled last time or what you have learned last time is about transforming algebraic expressions with rational exponents to radical expressions. Now, let's have an example. We have the property of a radical expression. For any real number, a raised to m over n, such that m and n are integers and should not be less than or equal to 0, the radical expression will be the nth root of the nth power of a. So a raised to m over n will be nth root of a raised to m. As you can see, the denominator of the exponent will be the index or the radical of the radical expression, and the base will be the radicand, and the numerator of the exponent will be the exponent of the radicand. Okay, let's have an example. X raised to 3 over 4. So the base of our exponential form will be our radicand, and the numerator will be the exponent of the radicand, and the denominator of the exponent will be the radicand. So the answer is fourth root of x cubed. Understand? Okay, I'll give you another example. the whole quantity of the sum of x and y raised to 7 over 5. So, this whole expression is our base. So this base will be our radicand, x plus y. And the numerator 7 will be our exponent of the radicand. And our denominator 5 will be the index or the radical. So the final answer will be the fifth root of the seventh power of the sum of x and y. Okay? We have the last example. X raised to 4 raised to 3 over 8. So, when we convert this, x raised to 4 will be our base. So that's why it will become the radicand. And the numerator of the exponent will be our exponent of the radicand. And our denominator will be the index. As you can see here, class, x raised to 4 and then raised to 3 is what you have encountered last time. So when you have power of a power, all you have to do is to multiply the exponent inside and the exponent outside. So that would be 4 times 3, and that would become x raised to 12. Okay? So that's how it works. Okay? So we have the second property of a radical expression. For any real number a raised to m over n such that m and n are integers and n should not be less than or equal to 0, the radical expression will be 1 all over the nth root of the mth power of a. So since we have the negative exponent, all we have to do is to reciprocate the whole expression. Okay, so since this whole expression is in the numerator, all you have to do is to put that over the fraction bar. So that would be the denominator. Okay, so a raised to negative m over n will be 1 all over the nth root of a raised to m. That's easy, right? So the n will be the index, and the base will be the radicand, and the numerator will be the exponent of the radicand. Yes, so that is the rule of negative exponent. Let's have an example. X raised to negative 3 over 4. So we should um, put the whole expression over the fraction bar and convert or transform the whole expression into radical expression. So the answer will be 1 over the fourth root of x cubed. Another example. We have the whole quantity of the sum of x and y raised to negative 7 over 5. So just do what we have done earlier in the previous example. So that would be 1 over the fifth root of the seventh power of the sum of x and y. And the last example will be x raised to 4 raised to negative 3 over 8. So let's get to it. So 1 over the eighth root of x raised to 4 then raised to 3. So the same power of a power rule. So we need to multiply the exponent inside and the exponent outside. So that would become 1 all over the eighth root of x raised to 12. Okay, so now we're done in our review. Now, let's go with our lesson proper. Why do we simplify radical expression? Hmm, why? Okay, let me give you a gist. Which would you prefer to evaluate? Okay, we have two different expression and they are equivalent. They are the same. They are the same. They have the same value. Now, the second one will be the most simplified form of this expression. Now, we're going to evaluate these two expression using the value x equals 2 and y equals 8. Now, let's evaluate the first expression first. Now, first, substitute all the variables. So the x would be 2 and the y would be 8. So that is the cube root of negative 27 times 2 raised to 6 times 8 raised to 4. And then evaluate this. So 2 raised to 6 will be 64 and 8 raised to 4 will be 4096. And multiply everything, multiply all the radicands. So that would be negative 7,077,888. So in order for you to find out the value of this, you should manually, you should manually calculate that. And that is so astronomical. We are not able to get the cube root of a very large number. So what are we going to do? Let's use the most simplified form. Now, let's substitute x and y. So x would be 2 and y would be 8. So, evaluate this. So, 2 squared will be 4, and then 8 will be 8, and then the cube root of 8 is 2 because 2 times 2 times 2. Okay? And multiply everything. So negative 3 times 4 times 8 and times 2. And that would become negative 192. As you can see, the cube root of this number will be negative 192. So how are we able to find that answer? Because we use the most simplified form. So what am I talking about? I'm talking about how we are able to solve all the expressions as simply as possible. As simple as possible. Okay? That is so basic. Now, before we proceed, you should be able to understand the power and the root. Okay? So, in our first raw, this would be the power, or how many times you will multiply the base by itself. Okay? And then the first column will be the root. Okay, the root or the base. Okay, for example, you have the power 6 and you have the power 3. So this is 729. So what does that mean? You multiply this base 3 by itself 6 times. So 3 times 3 times 3 times 3 times 3 times 3 is 729. So what does that mean? The sixth root of 729 is 3 because 3 is our root. And that would suffice. Okay? So, before you proceed, make sure um, that you master this table. Now, how are we able to identify whether a radical expression is in the most simplified form? Okay, we have the following criteria. The first criteria is no perfect powers as factors of the radical. This is the example. The square root of 32. Okay, 32 has factors, which is 16 and 2, whereas 16 is a perfect square. And as you can see, 16 can be evaluated because the square root of 16 is 4. Okay, so square root of 32 is not yet in the most simplified form, so all you have to do is to simplify it more. The second one is no fraction inside the radical. Simple. Okay, when you see a fraction inside the radical sign, therefore it is not yet in the most simplified form. So you should be able to simplify it more. So the most simplified form for this is square root of 3 over 2. The third criteria, no radicals in the denominator. Okay, in our example, we have the square root in the denominator. So what are you going to do? You have to eliminate that. Okay, so since 4 can be evaluated, the square root of 4 is 2. Therefore, the most simplified form is 3 over 2. And the last criteria is you have no doubt about your answer. Okay, let's talk about the properties of radicals. Okay, the first property, the nth root of the product of A and B is equivalent to the product of the nth root of A and the nth root of B. So you just separate the two variables A and B. The second property, the nth root of the mth root of P is equivalent to mnth root of P. So you just multiplied the index. Okay. The third property is the nth root of P over Q will be nth root of P over nth root of Q. And the last property is the nth root of AB raised to M is nth root of A raised to M and nth root of B raised to M. Okay? Now, we have four ways of simplifying radicals. But this week, we will use the first two ways of simplifying radical expression, such as reducing the radicand and reducing the order of the radicals or the index. Now, let's use the first way or the first method, reducing the radicand. Let's have an example. Square root of 50. So where is the radicand? 50 is our radicand because this is inside the radical sign. How are we able to reduce that? You should be able to get the factors of 50. The factors of 50 are so many. So you should get the factor of 50 that is a perfect root. Okay, I mean a perfect power. Okay, since we are using square root, you have to get the perfect square. Okay, so the factors of 50 is 25 times 2, whereas 25 is a perfect square. And then we are able to evaluate 25 since it has a root. Okay, so the square root of 25 is 5. Therefore, the final answer is 5 square root of 2. Now, let's check. Is there no perfect powers as factors of the radicand? Let's look at the radicand, 2. Is there any factors that is a perfect square? No, because 2 is already a prime number. So that's therefore it's checked. Number 2, no fraction inside the radical. Is there a fraction inside the radical? No. So this is checked. And the third one, is there no radicals in the denominator? Do we have the denominator? No. So that's it. This is the most simplified form of the square root of 50. Let's have another example. We have the cube root of 81. Now, get the factor of 81, whereas one of its factor is a perfect cube, since our radical or our index is cube root. Okay, the factor of 81 is 27 times 3, whereas 27 is a perfect cube. Now, we are able to evaluate 27 since it has cube root. So the cube root of 27 is 3. And then cube root of 3. Just copy that since it doesn't have cube root. That is the final answer. But before we make sure that this is the final answer, we will check it. Is there no powers as factors of the radicand? This is the radicand. And 3 is a prime number, so there is no factor at all. So that is checked. The second one, no fraction inside the radical. Is there a fraction inside the radical? No, it doesn't. So this is checked. And the third one, no radicals in the denominator. Do we have the denominator? No. Therefore, 3 cube root of 3 is the most simplified form for the cube root of 81. Another example. We have the fourth root of 48. Re- Um, Once again, another example is the fourth root of 48 A raised to 4, B raised to 5, C raised to 6. Okay? Now, let's find the factors of each expression, such as 48, A raised to 4, B raised to 5, C raised to 6, that has a perfect fourth power. Okay? So that means, you multiply the base by itself 4 times. So the factors of 48 is 16 and 3, such as 16 is a perfect fourth power. And a raised to 4 is just a raised to 4 because we multiply a by itself 4 times. So that's why the exponent of that is 4. B raised to 5 is b raised to 4 times b. Okay? Because according to the product rule of our exponent, if we have the same base, all we have to do is to add their exponent. So 4 plus 1, if you do not see any exponent in a variable or in a number, there is an invisible 1. So in this example, it has one exponent. So 4 plus 1 will become 5. That's why the factors of b raised to 5 is b raised to 4 times b, whereas b raised to 4 is a perfect fourth power. Okay, 6 raised to 6 has a factor c raised to 4 times c raised to 2, whereas c raised to 4 is a perfect fourth power. Now, let's regroup them. So, group themselves to according to the perfect fourth power. So, we get 16, a raised to 4, b raised to 4, and c raised to 4 because these are our perfect fourth power. And then the second group will be the expression that is not a perfect fourth power, such as 3, b, and c squared. Now, evaluate this. The fourth root of 16 is 2. The fourth root of a raised to 4 is a. The fourth root of b raised to 4 is b. And the fourth root of c raised to 4 is c. And then copy the radicals, so fourth root, and then put the expression that is not a perfect fourth power inside the radical sign. So the final answer is 2abc, the fourth root of 3bc squared. Let's check. Are there no perfect powers as factors of the radicand? No. That is check. Is there no fraction inside the radical? Check. No radicals in the denominator? Check. Therefore, this is the most simplified form for the fourth root of 48, a raised to 4, b raised to 5, and c raised to 6. Okay, so before we proceed to the second way or second method, if you are having difficulty understanding the first method, you may replay it. Okay, now let's go with the second way or the second method, which is reducing the order of the radical or the index. Let's have the example. In our way, we should be able to reduce this radical or the index. But how? Okay, listen carefully. The eighth root of a raised to 12. Now, um, find the factors of a raised to 12 that is a perfect eighth power. So a raised to 12 is a raised to 8 times a raised to 4. Whereas a raised to 8 is a perfect eighth power. Okay? So the eighth root of a raised to 8 is a, and put this inside the radical sign because it is not a perfect eighth power. So we have a and then eighth root of a raised to 4. Now, actually, it might be the correct answer or the final answer, but make sure that the radical and the exponent of the radicand is in the lowest term. So what am I talking about? because this is the exponent in a fraction form. So every fraction must be in the lowest term. Okay? What we're going to do is that we should transform this first into rational exponent such as a raised to 4 over 8. Okay? The index will be the denominator, and then the 4 will be the numerator. And then as you can see, 4 over 8 has a lowest term, such as 1 half. Okay? And that's when you go back to the radical expression. So a raised to 1 half would be square root of a raised to 1, or invisible 1. So the final answer is a raised to a. Let's check. Are there no perfect powers as factors of the radicand? Check. Are there no fraction inside the radical? Check. No radicals in the denominator? Check. As you can see in our example, we have the eighth root, but in our final answer, we came up with square root. Okay, so did we suffice the second way or the second method? Yes, we do. So the final answer is a raised to a. Let's have another example. The fourth root of 25. We all know that 25 is a perfect square, and the square root of 5, I mean the 25 is 5. So therefore it is 5 squared, right? And then let's try to convert this into rational exponent. So that would become 5 raised to 2 over 4. And we all know that 2 over 4 has a lowest term, such as 1 half. And then that's when we should go back to the radical expression. So that would be square root of 5. Okay, that is the most simplified form for the fourth root of 25. Another example. Okay, we have the cube root of the square root of 44. So when you encounter this, what are you going to do? Now, you should focus on the innermost part of the expression. So the innermost part is square root of 64. So you should evaluate that first before going outside. Okay? We all know that the square root of 64 is 8, right? But I'm going to show you two ways on how we are able to simplify this expression. Okay? So this would be my first method. Okay? So first, I what do you call this one? I evaluated the innermost part first. So the square root of 64 is 8. So that is cube root of 8. And we all know that the cube root of 8 is 2. Okay, so 2 is the final answer. Now I have the second way. First, I do the property of radical expression. I multiplied the indexes. Okay, indices, yeah. So that is 3 times 2, and that would become 6. Okay, so that is 6 root of 64. And we all know that 64 is the sixth power of 2. Okay, because 2 times 2 times 2 times 2 times 2 times 2 is 64. Okay, and then transform this expression into rational exponent. So that would become 2 raised to 6 over 6. And then simplify the fraction. 6 over 6 is 1. And then 2 raised to 1 is 2. Okay, whatever method or ways you're going to try or you're going to do, as long as you are doing right, you're doing the right properties, then your answer will not be getting wrong. Okay, and we have the last example. Sixth root of 27, m raised to 3, n raised to 3. Now, I get the root of 27, such as 3, because 3 is the cube root of 27. So that's why it is 3 cube, m cube, n cube. Have you noticed something? Yes. Power of a power rule. Okay, so this is the product of 3mn raised to 3. As you can see, this 3, I distributed it to each to each expression. So 3 times 1 is 3. So that's why 3 raised to 3. And then 3 times 1 is 3. That's why m raised to 3. And then 3 times 1 is equal to 3. That's why n raised to 3. Right? And this would be the base of our exponent. And this would be our index. Now, we should transform this into rational expression. Or rational exponent. Okay, so that would become 3mn raised to 3 over 6. And we all know that the lowest term of 3 over 6 is 1 half. And then let's go back to the radical expression. So that would become square root of 3mn. Let's check. Are there no perfect powers as factors of the radicand? No. No fraction inside the radical? No. No radicals in the denominator? No. Okay? So that's the final answer. And that would suffice. Okay? Now we are done with the lesson proper. Now let's have a generalization or our summary. A radical expression is in the most simplified form if it has no perfect powers as factors of the radicand, no fraction inside the radical, no radicals in the denominator, and you have no doubt about your answer. We have different properties of radicals to be remembered, such as the nth root of the product of a and b is equal to the nth root of a times the nth root of b. The nth root of the nth root of p is equal to the mn root of p. And then nth root of p over q is equal to nth root of p over nth root of q. And then the nth root of ab raised to m is equal to nth root of a raised to m times the nth root of b raised to m. And then we do 2 out of 4 ways in simplifying radical expression. Okay? Now, in your expected outputs, you should be able to answer the following. Simplify radicals by reducing the order or index of radical, and then show your solution and box the answer. Your answer will be written on a pad paper or in a LAS that would be given or distributed to each of you in the retrieval day. And we have the performance task. Reduce the radicand of the given element, osmium. See rubric for scoring. And then the rubrics will be given after this video. And then the reflective journal. I have learned that, and then I want to learn about, okay? But before we end this, since this will be our last week and we'll be having a Christmas vacation, let us remember that the shelter where Joseph and side before giving Jesus birth is about care. And then the support, the living things beside Jesus, the animals, his parents, the 3 wise men, symbolizes support in our lives. And then the third one, God gave us his begotten son to save the world, and that is love. Okay, so thank you very much. Should you have any question with regard to our lesson, kindly contact your subject teachers. Have a nice day. Bye.